Okay, I'm going to finish up the notes for section 5.4. I think this is where we left off in class. And what this section is talking about is when you're finding the area, and we're going to use integrals to find the area. We're not going to use Riemann sums or trapezoid rule. But what we want to do is we want to make sure when we're asked to capture area or total area that we have to find the area above the x-axis and distinguish it from area below the x-axis. So anything below the x-axis, we would add the absolute value of that area. So it says, so we can use the antiderivative to find area, however, we must be careful to distinguish net area, in which the area below the x-axis is counted as negative from the total area. So what we need to do is add back in, or take the absolute value of any area below the x-axis. So I briefly went over this in class, but this would be an example. Say we're taking the area from 0 to, say this is 8. And our x-intercepts, or our zeros of the function, are at 2 and 5. If the question asks for area, it's asking for this plus this plus this. When I use an integral, it's fine for these areas above the x-axis, but an integral below the x-axis, this area would be negative. So what we do is we partition it, and we use these zeros as our partition point for our integrals. So our first integral would go from 0 to 2 of f, and we would leave that one exactly like it is. Then we would go from 2 to 5 of f. This one, because the area is below the x-axis, we're going to take the absolute value of that one. And then the last one, from 5 to 8, we can just keep it as is because it'll give us a positive area. So here's the example. Find the area. When it says area, it means total area of the region between the curve 4 minus x squared between 0 and 3. And we're always looking at the area between the curve or the function and the x-axis. So we're going to sketch it first. So these are the ones where being able to sketch a graph, even if it's non-calculator, would be important. So this is a parabola, flipped upside down, translated up to 4. So we're going to have something like this. This is obviously a sketch, not a great one. And they're asking us between 0 and 3. So the area we're looking for is this area and this area. So this is our positive area, this is our negative area. This 0 happens at x equals 2. And remember, if it's calculator, you could graph it to find this 0. If it's not calculator, then you would set the function equal to 0 and solve for x. So you'd find these 0 points. Those tell you where you're going to break up your integral. So our first integral is going to go from 0 to 2. That's going to give us this area of the function. Our second one is going to go, oh, there goes my phone, ignore that, from 2 to 3. So that is the area under the x-axis. So that's the one we're going to take the absolute value of. So 2 to 3, 4 minus x squared dx. So you have to remember, either carry these absolute values through or make sure you add them back in at the end, but a common mistake would be forgetting those. Alright, so let's take the antiderivative of this. So the antiderivative of 4 would be 4x. The antiderivative of negative x squared, I would add 1 to the exponent, so I'd have x to the third divided by 3. So you can write that like that. You could also write it as negative 1/3 x to the third. In this one, we're going to evaluate between 0 and 2. And then the next one, the integral is going to be the same, right? There's my absolute values though. So I'm going to 4x minus x to the third over 3. This one evaluated from 2 to 3, and that's what I'm going to take the absolute value of. Okay, I'll go through this integral since we need practice on these antiderivatives. Sorry, my camera's swinging. Alright, so first I'm going to plug in 2 and then plug in 0 and subtract. Well, I can already see when I plug in 0 here, I'm going to get 0, so I'm just going to do plug in 2. So 4 times 2 is 8. Put this in parentheses. Plug in 2 here, I'm going to have negative 8/3. I'm not going to bother plugging in the 0 because I know I'm going to get 0. So then I'm going to have plus absolute value. First I'm going to substitute in 3, and then I'm going to substitute in 2. So when I substitute in 3, I get 12 minus 3 to the third is 27. Divided by 3 is 9. So 12 minus 9. And then, sorry about that, then I'm going to substitute in 2 into here. So, and that's going to be subtract. So I got 4 times 2 is 8. Oh, I already substituted in 2 over here, so I'm going to get 8 minus 8/3. Okay, absolute value of all of that. That gets me 16/3. Plus absolute value of negative 7/3, which gets me 23/3. So that's my area. Use the zeros, and then always absolute value of anything under the x-axis. So we have another one here. Yeah, I'll put that in this video. Might skip all the arithmetic steps in this one and just hit the setup. So this is an upward facing parabola. I don't have a lot of room in my notes. I'm going to draw my sketch over here. And upward facing parabola. The x-intercepts for this one are negative 1 and 1. But they're asking me to find the total area between negative 2 and 2. So here's negative 2, here's 2, and so my area above the x-axis is here, and below is here. So I'm going to do integral from negative 2 to negative 1, keep it exactly as it is. An integral from negative 1 to 1, I'm going to take the absolute value of this integral, because it's under the x-axis. And then an integral from 1 to 2, and keep that one exactly the way it is. And remember, if it's not calculator, to find the zeros, the 1 and negative 1, set that equal to 0 and solve for x. Alright, so my integrals are going to go negative 2 to 1 of 3x squared minus 3 dx plus absolute value, negative 1 to 1 of 3x squared minus 3 dx, absolute value, plus 1 to 2 of 3x squared minus 3 dx. So the antiderivative, and this is all area, would equal. And so the antiderivative would be, I'm going to add 1 to this exponent, so I'm going to get x to the third, and then I'm going to divide by 3, so I'll have 3 divided by 3. So the antiderivative is going to be x to the third minus 3x. Remember, a constant, derivative of a constant because you add the x. You think of this almost like x to the 0 and you add 1. So then I'll evaluate that from -2 to -1. I just noticed over here I should have had a negative there. And then this is my absolute value, 1 here. So I'm going to have the same integral, x to the third x to the third minus 3x. This time, did I forget my integral symbol here? Yeah, I did. This time from -1 to 1, and then plus, and there's the other side of my absolute value, plus x to the third minus 3x from 1 to 2. So I'm going to substitute in -1 and then -2, subtract those, +1 and -1, +2, +2 and +1. So I'm going to continue this down here. This is what I have, 2 minus -2. So when I substitute in -1 here, I get -1 plus 3, so that's 2, minus -8 plus 6, -2. So that's my first substituting in. The next one, I get absolute value of -2 minus 2. There's my absolute value. So here I'm substituting in 1. So I'm going to have 1 cubed is 1. 1 minus 3, -2. Then I'm going to substitute in -1. I'm going to have -1 plus 3, which is +2. And remember, I subtract after I substitute in upper and lower bound. And then the last one, no absolute values needed, and I get to minus -2 on the last one also. So what I end up with is 4 plus absolute value of -4 plus 4, total area is 12. This talks about using your calculator, which I think we know. But the one thing that you want to notice here, it says if you wanted to do, say, a problem like this in your calculator, what you do is you can put in the entire integral. So for this problem, if it were a calculator problem, I could put this into my calculator, and then what I would put in, what I would say is tell the calculator to do the absolute value of the function. So that's what this says. On a TI-83, you would do your fn int, and then you would say absolute value of the function, comma x, comma a, comma b. Then you'll get the total area. So you can try that on this one. So on this one, this is what I would be putting in from -3 to 3. X cosine of 2x dx. So in your calculator, it would be fn int, and then I do absolute value of x cosine of 2x, comma x, comma, lower bound, upper bound. And what you should get, I should do this as an approximate, 5.425. So you can check these in your calculator, or if it were a calculator question. Alright, so that is the rest of the 5-4 notes.